Hello everyone. I hope you're all doing good. So continuing with our LeetCode token tower question series. Today we'll be solving valid anagram question. So you are given two string s and t, and you have to return true if t is the anagram of s. Otherwise, you have to return false. So anagram is nothing but given a input string, and one of the anagrams can be the characters present in the input string are rearranged. Their position has been rearranged. For example, let's say input is car. Okay, let's say I rearrange the characters and make them into something like a c r. Okay, same characters but their position has been rearranged. So this is the anagram of uh, this is s. So this is s and this is t. So t is anagram of s. Another case can be let's say RCA. Okay, this is another T. So T is again the anagram of S. So that's the anagram, meaning of anagram. If you see the input here, this is anagram as string anagram given. This has been rearranged. It's the same characters. Output is true. Let's say as is given rat, but T is CAR because T is not present in this string, so it is false. So that's the meaning of anagram. So let's now jump directly to the idea behind the solution. So let's look at the idea. For example, you are given an input car. Let's say this is S, okay, and you are given, let's say, RCA, and let's say this is T. Now you have to check whether T is the anagram of S. Okay. So one of the most basic approach, what you will do is first you will check the length. If the length is equal to t length, okay, then only they can be anagram. If length is not equal, then they can never be anagrams. Okay, so first this thing you need to check. Now another approach you can do is, now we know the length is same, so first you have to check is uh, each character. Let's say you iterate over t. Okay, so you iterate over t and see if the each character of t is present in s. Okay, so let's say you are iterating over R, you see if R is present in S. Okay, you move ahead. You see C is present in S. Yes, it is there. You move ahead. A is present in S. You move ahead. So once you safely iterate the T till the end, you can safely say that T is the anagram of S. Okay, because we know that we have already checked this condition that S dot length is equal to T. So that's the one of the approach. Okay, now let's look at the another approach here. So in this case, what we are going to do is, we know that numbers are just rearranged. Both the for T to be anagram of S, T should hold same characters, just like as present in S, but only their position is rearranged. Okay. So another approach we can do is we can sort this S. Okay, so let's say once we are done with the sorting, so we'll get here what A C R. Okay, and here again we do the sorting of t, will get a c r. Okay, now once we are done with the sorting, okay, let's say s dash, this is t dash, and then we compare character by character. Okay, and if at any point we see that the character mismatch, we can return false, because then that means that the sorted string or the t is not the anagram of s. Okay, so this involves sorting. So let's look at the another approach. So we know that the characters are same. Okay, only their arrangement is being changed if T is the anagram of S. So what we will do is we count the characters. Okay, because if T is the anagram of S, then it means the count of the characters in S is equals to count of the characters in T, individual count of the characters. So for example, in S we count the characters. So we see okay, C has occurred one times. Okay, A has occurred one time, R has occurred one time. Okay, so this is, let's say, count array something for the S. So this is a count array. Okay, now what we will do is we iterate over the T. Okay, and let's say we came across first character R. So what we do is we see the count in this S array. So if we see R is present, then we reduce the occurrence by 1. Okay, so now R occurrence is 0. Let's say if R is not present in this array, then we can directly return false. Because why? Because there is an occurrence of R here, but there is no occurrence of R in this array or in the S. Now let's say we came across A, okay, and we see that okay, A is present. We again reduce the occurrence of this as well. So we make it a 0. That comes to C, we reduce the occurrence of this as well, and we make it 0. Okay. Let's say if there would have been another element present, let's say D. Okay, so we see that D is not present, so we would have returned false. So let's say there are two C present. Let's say RACC. For example, this is RACC. Okay, so first of all, this would have been failed when we do the validation of S dot length equals to R dot length. Okay, this would have been failed that uh, point itself. Okay, now let's say there is another input RCC. Okay, this is, let's say, your T. So what you do is the array is C1 or C2. Okay, sorry, C1 because the S is nothing but CAR. So C is 1 here. Okay, A is 1 here and R is 1 here. Now let's say you iterate over T. You say okay, you came across R. You say 1 minus 1. You make it 0. Now you came across C. You see here. You say 1 minus 1. 1 minus 1, it becomes 0. Okay, now currently it is 0. Now again you came across C here, but you see okay, this C present in the count array has an occurrence 0. Okay, so that means the occurrence of C is more in T but less in S. Okay, so if you came across this value where the occurrence is already 0 here, so what you do is return false because T cannot be anagram in such a condition. So we have discussed three approaches here. So this is the best approach here because it does not include any sorting or multiple iterations. We just have to uh, store the count of the characters in the S, and then once we iterate the T, we check the conditions, certain conditions here, and based on that we return true or false. Okay, let's now directly jump to the solution and the code. So here's the code. This is the function is anagram. This is the input S and T. First is the length check. You check if the length is not equal to. So if this is the case, then T can never be the anagram. Then what you do is you take this array, okay, character array, because we have taken 26 because the input is given that it contains lowercase characters only. Now what you do is while iterating over the S, you keep updating the count as we have already discussed in the idea. Here we are maintaining the count of each particular characters. Okay, now once you are done with the iterating array, now you iterate over the T here. Okay, and what you do is based on the character present in the T, that specific characters number you decreased in the particular array. For example, as I told, let's say S is your CAR, so input is 1, C is 1, A is 1, R is 1. Okay, so once and let's say T is your RCA, so you iterate R, you check here, okay, R, and you decrease this with 1 and you update it. Okay, so that's what we are doing here. So we are iterating over this T and we're decreasing the occurrence, and at any point if you see that the occurrence after decrease in the occurrence become less than 0, that means the T has more count of that particular element than the S. So in that case, T can never be the anagram of S. In that case, we return false Otherwise, if both these conditions are, if after iteration of for loop, we can know now safely say that all the character present in S are also present in T. So in that case, T is the anagram of S. So we return true here. Okay. So yeah, that's the solution. I hope you have followed it. Do let me know if you want me to solve any particular question. Till then, bye bye. Take care.